All right. Thanks everybody for joining us today. This is the Backup and Recovery office hours for March. We've got the Oracle Backup and Recovery team with us here today. My name is Kelly Smith. I'm one of the members of the Backup and Recovery product management team. I'll be talking through the first few slides, and then we'll show a demo live in OCI. Then I'll turn it over to Alex Goldblatt. He's going to talk a little bit about the competitive perspective with the recovery service. So if you have any questions along the way, please use the Q&A, and we're here to answer any questions. So let's get started. What we're going to talk about today is the Oracle-based database service in OCI is getting zero data loss recovery. And what that means is there's a new service that's coming on board, or a new integration, I should say, between the Oracle-based database service and the zero data loss autonomous recovery service, which is a new offering in Oracle Cloud. It's something that we originally introduced at Oracle Cloud World, and the database services have been integrating with that. So the base database service is coming on board here very shortly. Keep an eye out for that. I'll just say in the next few days, you'll see that come to life. The documentation will be updated. The UI will be updated. You'll see all the APIs and SDK information and Terraform appear in OCI. So let's get started. Talk a little bit about the autonomous recovery service and why that's important for the base database service. First, when we start talking about backup and recovery, one of the hot topics right now is ransomware. Ransomware resiliency is, of course, top of mind for customers because these ransomware attacks are just not going away. And what we've done with the recovery service is we've created an integration with the base database service, which I'll show you in detail in the demonstration in just a few minutes. And that integration gives us automated and mandatory encryption to help prevent data theft, right? Unfortunately, backups are a convenient method to transport data. And that, typically you would use that to offsite data in case of DR, in case of needs around DR. But in a malicious context, that easily transportable package can be used for data theft. So we want to make sure that that package is always encrypted. So with the recovery service, the encryption happens automatically, and it's actually mandatory. The service itself is paying attention to the data that's arriving to ensure that the Oracle database backups are truly encrypted all the time. And if they're not, the service actually rejects the data, and then that will cause our man to fail the job, so that everyone knows what exactly was happening. Backups that arrive into the recovery service also are safeguarded against deletion. The policy in the recovery service is what controls the life cycle of the backup, and we enforce a 14-day minimum on that retention. So that means backups that were created for the last 14 days for a particular database can't be deleted. That is the minimum retention requirement. So, from a ransomware perspective, you want to get the most crucial backups are the ones in the last couple days, and those are safeguarded. As the recovery service came from, its back-end technology is from the recovery appliance that's been on premises for a long time. There's a lot of optimization that happens with the backups in the background. And we do that to make sure that there's fast recovery with zero data loss. And I'll show you the statistics that we bubble forward into the service, the database service, so that you're aware of what's happening with backups. And then what your data loss exposure actually looks like. Next, from an operational efficiency perspective, and this goes along with optimizing the backups, we eliminate that weekly full backup. So the recovery service takes a L0 backup right when the database is onboarded, and then we don't revisit that L0 backup. We continually take incremental backups every day, which gives you really short backup windows, right? You don't have to worry about this heavy lift of this weekly full that shows up continuously. And if you think about it, most databases only change by a few percentages, less than 10% per week easily, which means that if you perform a full backup, 90% of the data that you're moving around has already been protected before. So we don't want to do that over and over and over again. We want to have a modern and intelligent way to handle the database and the backups from the database. So, we're moving to this incremental forever strategy where the changes that have occurred since the last backup is all that is sent to the recovery service. And then, of course, if you're going to be doing backups, you need to make sure they're good. What's the point if you don't know if your backups are good? RMAN has had a validation process for many years to ensure that backups are good, but that validation process takes a lot of resources away from the production database, just like a full backup, right? You're having to go through that data with RMAN and verify it. In this particular case, the recovery appliance and the recovery service, now in OCI, was developed by the same RMAN team that developed that recovery validation. So the recovery service will validate every single backup that comes into the system, and we do that without any impact on the production database. So we've offloaded all that work so that every single backup is validated to ensure that you can recover those backups and there's not anything wrong. The recovery service is also paying attention to all the pieces that should be present for a backup. So if a backup arrives, we want to ensure, the recovery service is wanting to ensure that all the data files that are present for that database are there. They make sure the control file's there. And it also makes sure that the SCN range is contiguous, right? We don't want system changes to occur that haven't been captured by the recovery service, because that breaks your ability to restore to any point in time for the Oracle database. And we're doing that because one of the malicious behaviors that can happen behind the scenes is if someone gets in and edits your RMAN job and just tells RMAN to back up one data file, that means that your backups will appear to be performing regularly. They'll complete successfully because it's captured that one data file. In this particular case, if someone attempted to do that, the recovery service would immediately notice that it's missing all the other data files that are associated with that database. And we would know, like, we can't recover this database. And, in a traditional sense, that one data file came across successfully, your job completed successfully, everyone's happy from a backup perspective, but you have no capability to restore. And so you have to be paying close attention to all the database files that are being protected. The recovery service is doing all that for you. And that goes with the recovery appliance on premises as well. It's a paradigm that we've had for a long time, ensuring that all the pieces that are necessary to actually recover the database are present. Moving forward to cloud simplicity. It's really quick and easy to configure a database. I'm going to show you that here in just a couple minutes. It's a few clicks in the UI, and the database backups are all up and running. In the cloud, cost controls are very important. It's really easy to deploy and use and consume in the cloud, but you need to know what you're consuming, right? You need to know why you're being charged a certain amount for a resource. So in the case of backups, the recovery service is going to be bubbling up that information into your OCI console and showing you the consumption for each database that's being protected. And then there's a dashboard, of course, that gives you, both a deep understanding of the protection of the database and all the consumption that goes along with that database. And I'll show you that in detail here in just a couple minutes when we switch to the UI. But we just want to make sure you understand what you're using. And that also gives you the capability of having, some business decision conversations around databases. If a business unit arrives and says, hey, I want X number of days of retention, and you set that up, you immediately understand how much space is going to be consumed by that retention policy. So you can have a conversation with that business team and say, hey, you realize that you're going to be eating up a lot of storage based on your retention policy. And does the cost of that consumption match the value of that database? So you can have that discussion so you can understand how, that there's not a surprise about how much that cost is actually going to result for that business unit. And I'll show you how we're doing that. We're showing current consumption and an estimate for future consumption to give you the ability to have that conversation. Next, let's look at the architecture. Of course, we're going to be supporting all the OCI databases. So there'll be, over the next few weeks, you'll see integration points for Autonomous Database Dedicated, Exadata Database Service, and the Base Database Service. The Base Database Service is what we're going to be concentrating on first, because that's the first integration point that's going to go live between the database services and the recovery service. And again, incremental forever backups. We're doing this in an automated fashion, so it's being done the same way every single time. We don't have to worry about human error, malicious mistakes, getting into the system. We're doing compression. So that data that is resident in the database, we're compressing it. It's staying encrypted through its life cycle and going to the recovery service. And the recovery service it never has access to the keys. The keys that unlock that encryption are owned by the database, because we want to keep those things separate, right? If someone gets access to your keys and they're sitting next to your backup data, then that means they just have easy access to the backup data. So we're keeping that information stored separately to make sure that the backups and the keys don't ever get mixed together. From the infrastructure perspective, essentially the recovery service is a huge fleet of recovery appliances that are running in OCI. And we're using the fleet concept because that gives us scale and high availability and load balancing. So you don't have to worry about how much, any kind of capacity management for the backend systems. You don't have to worry about, maintaining an engineered system, patching, or, load balancing for different database workloads. Oracle handles all that for you in the background, and you just send your backups. We can actually seamlessly move database backups around behind the scenes to make sure that your database is always on the most performant infrastructure. And that you don't have to do anything, any work for that to happen. As I mentioned before, there's end-to-end encryption. We're making sure that data stays encrypted for its entire life cycle. We're doing validation, and that just helps ensure that there's both security and recoverability for the backups. All the magic in this happens because there's control plane orchestration. There's control plane automation that sits with the actual Oracle databases. There's control plane automation that sits with the recovery service, and the two of those talk to each other to make sure that we're finding the right location for your databases in our fleet, the right storage location that's going to be most performant, and to also give you all the details about what's happening behind the scenes, which bubble up to your management UI, right? You see your policy-based retention, your backup health, and your storage utilization, and any kind of failures that could have possibly happened along the way. We want to make sure you're very informed about what's happening, because a surprise in the backup and recovery world usually happens at the least opportune moment. So we want to make sure that everyone is aware of what's happening. Okay, now I'm going to show backup configuration here really quick. It's in the slides. This is what it looks like in the slides, but I'm going to switch over to the actual OCI console. This is actually a database I provisioned this morning. You can see right there. And to configure automatic backups, it's just a few clicks in the UI, right? You set a scheduling time, of course. These are the schedules that are going to occur for the database backups. So we'll pick something early in the morning, 2 a.m. Notice that the Autonomous Recovery Service is available as a dropdown. In your tenancy, you may have a request. You may have to request limits. So if it says you need to request limits for the Autonomous Recovery Service usage, just click that link, request your limits. That comes to a member of the product management team. We work with engineering to make sure that there's capacity in your particular region and that's ready for you. And we'll handle that behind the scenes, and then it will be enabled for your tenancy. So feel free to follow that path to the limits request. Next, you pick your protection policy. So we have default policies that are configured in the infrastructure for 14 days, 35, 60, and 95 days. But you can create something special. Like if you wanted 24 days of retention, that's perfectly fine. I'll show you. I've already got some databases set up with different retentions. We'll look at that in just a moment. Since this is a sample, I'm just going to go with 14 days. This is the capability of the service to do real-time protection of the database. That means that as transactions are occurring, they're being protected by the recovery service. And that's a very powerful place to be in, right? As the transactions are occurring, if there is a malicious attack or if somebody makes a mistake in your infrastructure and drops something out of the database, you don't have to think to yourself, oh shoot, when was the last backup? Was it 15 minutes ago or an hour ago, or was it last night? In this particular case, it would be right now, like your backup occurred right now. This is a premium option. So if you turn that on, there's a premium that goes on top of that. All that's covered in the cost estimator, which I'll have a link to later. And I'll also make sure it's on the Ask Tom website. But I can simply turn that on. There's also a question here about what to do with backups after the database itself is terminated. You have times in the database's history where you're going to deprecate a database, but you still may want to keep the backups around for what would be their protection policy retention period. So if I was going to keep my backup for 14 days, even if I terminated my database with this option set, the backups are going to be deprecated over the next 14 days. They don't get deleted when the database itself is terminated. They're two different life cycles, if you will. For test databases, you can also set it so, it holds the backups for a few days, 72 hours, and then deletes the backups. We don't produce a workflow that allows anyone to delete the database, terminate the database, and delete the backups at the same time. We've had customers, in the past make mistakes. They terminate a database and poof, the backups disappear at the same time, which kind of leaves you empty-handed. That's not a good place to be in. So for a minimum, you have to wait 72 hours for the backups to get cleaned up. So if there was malicious or a mistaken database termination, your backups are always right there. And we keep them in context of the database itself. So you'll see the database in a terminated state. You scroll down under the backups list, all the backups are still listed, and you can easily do a restore. So those are options for you. I'll leave mine set for the retention policy. We'll save these changes. And then what'll happen is here in just a moment, we'll see a backup pop up. So what's happening behind the scenes? We're doing all the configuration for RMAN, and then connecting RMAN to the recovery service. Finding in the background right now, the request has been made. We're finding the right recovery appliance to serve at this database in our fleet that's running in OCI. We're creating, we're registering the database, setting up the RMAN jobs, doing all the work that you would normally do by hand. That's just happening behind the scenes automatically. And when all that work is done and the database backups are provisioned, you'll see the backup will just pop up right here at the bottom. It might take us, oh, here we go. There it goes. So at this point, RMAN's configured, it's connected to the recovery service, and the backup process is underway. So we're going to let this run, and we'll come back to this. For now, I'm going to show you a couple of databases because and I'll be honest, it takes probably 20 minutes or so for the setup to run, for the database to come on board for the first time. There's a little bit of extra work that has to be done. So we can look back at this at the end of the presentation. And we should see it completed. Let's go look at databases that I've already got set up. So you see in the console now under Oracle Databases, you've got database backups. So if we go look at that, let me switch to our office hours compartment. So these are databases that I've already got running. You'll see that some of them have real-time enabled, some don't. The ones that are disabled, you can see they have a data loss window because that means that the archive redo logs are only being picked up on a schedule. So they got picked up 7 minutes ago or so. That's important to understand. This database at the bottom is running real time, so you can see the data loss exposure is 0 seconds. You see the space utilization. We talked about that earlier. This is the space that you're going to be charged for. You see the database size. And you see in this particular case, I'm using different policies. So there's the bronze policy that's one of the defaults. These are policies that I create. This is a policy that I created. Let's go look at this database in the middle. We'll look at the details of that. This database has already been set up. It's been running for a while. And you can see there's information that bubbles back to the database console itself. See, I'm in the Oracle Database Console for the base database. And notice, there was a backup that failed on the 26th. So it happened a while ago, but it's still inside of my 24-day protection period, which I set with my custom policy. So you can see right there, a backup failed. And if I go look at my backup history, yep, there it is. It failed on the 24th or 26th. And I had the database down at that point, forced to failure. So I know that happened. But that gives you an idea that something happened inside of this 24-day window that may cause a recoverability problem for the database. All the backups since then have run successfully, which means that you're in a protected space, but there could be a gap back in the past. Again, there's the space. We have a link over to the Autonomous Recovery Service. I'll click on that in just a moment, and there's the real-time protection that's disabled. So let's go look at this link, which gives us a little more details. So again, a lot of the same information, but you see other things popping up, like how long did it take my last backup to complete? That's kind of interesting information. Again, we're in an incremental forever paradigm, so this particular database is taking about 12 minutes to back up. And there again is my last failed backup, my last completed backup. There's my projected space utilization. So we are projecting that it's going to go down. And the reason that's going to happen is you notice that right now I have 25 days. The retention goes up and down, like 24 days, 25 days, 24 days, 25 days, because we're purging stuff that's no longer needed in the background. The recovery window will go up and down. There's my protected database size. So again, trying to make sure that you've got all the information that is relevant for you to make decisions about, is your database being protected and are you ready to do a recovery? There's a link back to the production database. So if I click on that, I go back to the protected database itself. And then I've got my typical restore commands, right? I can restore from here to the latest, to a timestamp, to the SCN. If I want to clone, I can go down here to the bottom, pick a backup, and create a database from this backup. And I can do that for any backup that's in the system. So this database is being protected and we're in good shape. If we go back, I'm going to look real quick at the database that has real-time redo enabled. So real-time protection is enabled for this database. The database is being protected in real time. So you see 0 seconds there. So the database is actively sending transactions to the recovery service. And you can see that that's enabled down here. In OCI, there's a metrics explorer, and there are alarms that you can set to monitor this data loss exposure so that you can have alerts being sent out. I'll do a special session on that. We'll talk about all the alerting and reporting characteristics that are available with the recovery service, because that really gives you some powerful knowledge about what's happening, right? You can simply set an alarm on this data loss exposure. And then if any of the databases go over a threshold that you set, you'll get an email alert. That's a powerful tool, so you understand exactly what's going on. And you can set that by compartment or by individual database. So we'll go look over here. Again, very similar information. You can see the backup, which is the daily backup, took about 10 minutes for this database. No failed backups in the recovery window for this database. So there's a 14-day recovery window. And you can see we're just a little over 14 days right now. So a lot of the same information. It's just we've got real-time protection turned on, so our data loss exposure is 0 seconds at this point. And this is the link back to the database. The two are tightly tied together. You can see that there's no terminate, no deletion capabilities in this. We know that the database backups are coming from automation, and we don't allow you to just simply delete backups. Even if a sysdba went to this database, went to the RMAN prompt, and attempted to delete backups from the RMAN prompt, they're the all-powerful sysdba. They should be able to do that. They'll get back a nice little message that says that deletion's not allowed because it's being protected by policy. So the sysdba doesn't even have the capabilities to delete backups out of the system because we've tightly tied the two together. Okay, so that's the end of this part. I'm going to go back to the presentation, and we'll check in on our database here in just a couple minutes. Okay, I'm going to turn it over to Alex. He's going to talk a few minutes about, how this stacks up against the competition. So Alex, I'll turn it over to you.
So kind of explaining where we stand in the sense of the competitive and the functionality, if you would, comparing to the others. There are a lot of kind of misperceptions in what we're trying to accomplish, where we started and where we're heading to. And I actually got to one of the questions from one of the participants, and they're going to get to it shortly. But the important part is we're not really comparable to anybody else. You cannot compare all of these technologies, not really applicable to what we do in the cloud. And even though that we do use the backend of the recovery appliances, as Kelly already explained, in reality, it is extremely difficult to compare, like.
Alex, for some reason, your voice is cutting in and out.
That's bad. It's probably my internet connection is flaky. Can you hear me?
Yeah, we can hear you fine now. Okay, so keep going.
Yep, thank you. Yeah, let me know if something, because I keep getting messages, so that's my connection is unstable. So what I was trying to explain that even though that we do use a recovery appliance in the backend, what we do in the front end and tooling and the functionality that we had to develop from the operational and the overall management framework is extremely difficult to compare to what we have with the on-premise deployments. So let's kind of take a look at it. I put together like a few major bullet points, and we're going to start with the same security constructs that Kelly already mentioned. So we are bound by the rules, and these rules are imposed not just by us, but also by the regulators. They also imposed by specifics that are relevant to the OCI, because we behave as the OCI native service to start with. So people often ask about the TDD encryption and if we actually maintain our data encrypted on the back end. So the answer is absolutely yes. It is mandatory to have all data encrypted. We can use TDD encryption. We can use basically just your own management for the key rotation. But the bottom line is we have to operate within the absolutely 100% secure environment. If you're going to take a look at the any other parties, that are mostly available in the OCI marketplace, they cannot operate within the secure constructs. They just reside outside of the security. So therefore, OCI is guaranteed 100% security. Once you introduce third party to the mix, it's going to be up to them to ensure that they're going to be following the same rules, or they can provide identical functionality. And the other one is if you start, it's just absolutely incomparable. We charge only for the backend capacity usage, and the other guys, obviously, they're going to pile up a lot of licensing on your neck. And it's basically inevitable because you have to pay for the third-party providers, you have to pay for the OCI infrastructure. So things related to the basic deployment like CPU, storage, network connection between database services are going to be in place no matter what. The support for the OCI databases. So Kelly already mentioned that today we have 3 integration parties. And it is important to understand that integration is way beyond just a basic implementation of the client infrastructure in the OCI Oracle database. We actually become part of the overall control plane, tooling, and management framework. And as you could see in the UI, you can easily transition from the database service back to recovery service and et cetera, et cetera. So to do that, it requires extremely tight integration on a lot of fronts: messaging, logging, support, you name it. The other guys basically going to have to operate outside of the management. And the only thing that they can realistically offer, there is a little bit of misconception in the sense of how do we deal with the Oracle backups.
Hey, Kelly, I think you or maybe Marco can talk through this. The rest, I think Alex is cutting out too much.
Yeah, I think so. So Alex, if you can hear us, we're going to transition. Things to talk about here. So we've got, cross-region replication and standby database backup support on the roadmap. And that's kind of expanding our concepts for MAA. If you start, we want to make sure that we're matching our functionality with the MAA capabilities that are documented today. If you're not familiar with MAA, definitely something you want to take a look at for, your Oracle database architectures. These are proven architectures that have been, used in the field for many years. And when you compare that to third party, it gets very expensive. You're expanding out to multi-regions, egress fees and licensing fees. Everything starts to multiply over and over and over again. And you're falling outside of a known architecture. So we started getting into questionable performance and recoverability SLAs. If you're talking about MAA, we have a very tried and true implementation. When you start varying outside of that, sometimes we don't know what is going to, what the performance characteristics or your SLAs are going to be. OCI, of course, is a single consolidated environment. Everything is managed under a single pane of glass. You kind of saw that earlier. I can see my database services. I can see the backups. If I configure DataGuard, like everything is in that UI. Everything is fully managed, and you have a single pane of glass to understand exactly what's going on. Also, everything is encrypted. Everything is encrypted. We want to make sure that all the data that stays inside of our infrastructure is fully encrypted from end to end, and we maintain that control. If you look at something like Metallic, there's, an Azure hosted control system that lives outside of the OCI. And that is separating your data residency, right? You've got metadata that's stored in a completely different cloud infrastructure. Your backups are in a different place. You have to start paying attention to that type of data separation so that you can understand what customer sensitive data is being stored where. And that can get complicated, especially when you're internal security teams. Moving forward, if we look at the cloud service providers, Oracle is very database. We understand how to run the Oracle database. Let's all be serious about that. We understand the architecture and the infrastructure and how to manage those databases in a very clean, concise way. for you. It's very predictable. When you go into the big three public service providers, they're using generic implementations. They're running Oracle databases on top of generic VMs. And you can get into some unpredictable performance. Because it's not really an application specific infrastructure, right? They've designed an infrastructure that runs for everything. And we want to make sure that the Oracle database is running best in our infrastructure, especially when we start talking about backup and recovery, and high availability. It's very important. Licensing, very straightforward, of course, because there are no third-party costs or overhead involved in any of these workloads and backup, right? Everything is in one spot. In the case of others, you're having to partner with Oracle and add other third-party solutions for file systems and backups, and that can leave you in an unpredictable situation again, with costs, and especially as you start to grow. Migrating from on-premises to OCI, we've got a lot of benefits that come to mind there. You're improving your security posture. Performance is very predictable. Management and protection is very predictable. And we have a very easy path to get from one place to another. There's zero downtime migration. That's a solution that's offered by Oracle to get you from on-premises into the cloud. With the other, parties, you have complicated migration workflows, and you're going to have to use third-party tools potentially to get from point A to point B. It's not going to be just a simple implementation. So you have to think about all of those intricacies, how that's going to impact your SLA. Is that going to introduce a higher outage during that migration process? And how are you going to mitigate that? I mean, in a lot of cases, your database is so important to your your business, especially, the Oracle database is there for you to process, business data. Like, that runs your business, and you don't want to have long periods of outage or unknown performance characteristics. And of course, like we're showing today, we have enhanced data protection capabilities. No one else is going to be able to give you things like real-time protection, automatically offloaded validation. Those are very powerful features for data protection of the Oracle database. And it's not expensive to do this. Take a look at the cost estimator for the recovery service. This is not, an extremely expensive integration for your Oracle database. Third-party public providers, they do a lot of snapshot type integrations because they're trying to, make backup short. They're trying to, be able to have predictable recovery, but they're doing this through methods that we wouldn't always see as always the best method. Tim, who's on the call, has written a blog entry, if you haven't read it, about how Snapshot really isn't a backup, and all the problems that can be introduced. And again, you're getting into you could put yourself into a condition where there's a string of snapshots that are actually problematic because there was a problem in a parent snapshot that has propagated itself through the children of that snapshot. And that means when it's time to recovery, because if you're not being very careful about validation, that snapshot may actually not produce the results that you are expecting. And that can put you in a very compromising situation, because, restores always happen at a time when it's, not the most convenient in the world. It's 3:00 in the morning on a holiday. It seems to be like the point in time where you have to deal with a restore. And we're really focused with the recovery service on protecting the Oracle database and doing that in a way that is very streamlined, low touch on the database, and gives you the insight into, how that database is being protected and your recoverability of that database. Okay. That's it from our presentation perspective. I don't know if we have any questions that we want to bubble forward in the conversation.
Yeah, Kelly, there was a question that should be answered. Looks like there was a confusion on how do we deal with L0, L1s.
Okay.
And so what does it mean, recovery window from our perspective?
Okay, perfect. So L0, L1. So L0, of course, is backing up the entire content of the Oracle database. L1 is an incremental. So when we run our L1, we say, database, give us the changes since the last database backup. So if you ran your L0 on Sunday, Monday comes along, you run your L1, Tuesday L1, Wednesday L1. The changes that occur between every L1 are just an accumulation of the changes that have occurred since the previous backup the day before. And then there's a lot of confusion like, okay, if you think about that from a traditional perspective, and we should probably do a deep dive on this in one of our next office hours. That gives us something to focus on for the future so we can really get into what's happening behind the scenes. We are essentially taking those backups and turning them into just blocks. So all these just become block changes. And the L0 backup is just a place to start. So the L0 backup gives us a baseline of all the blocks. New blocks come in with each, new changes come in with each L1. And as those L1 changes come in, we have a large metadata map that lays over the top of that, that tells us how all the blocks fit together and on which timeline. So if you set a 14-day retention, day 15 comes along, we look at the blocks that have all been replaced by more recent blocks, and then we just get rid of the old blocks. So what happens over time is that initial L0 you took, the blocks or changes that came in after that just get replaced over time. And I've got some demonstrations that show how that worked, but so that's something we can dive in on. But you can't think of the L0 is just a way for us to get all the blocks that represent the database, essentially. And after that, we are just mapping all those new blocks into the old. And as the old blocks fall outside of your recoverability range, what we call our recovery window, if we're on day 14 and there's a 15-day old block that has been replaced by something newer, we just get rid of that old block. And we just keep going through that process. So, it just becomes this large block change tracking system, and the change blocks are all we're keeping track of behind the scenes. And then when you request a restore, we already know what blocks fit together to produce a point in time, and we just simply give that back to you. So it's happening very efficient for the database that's being protected. And we're doing all the heavy work behind the scenes of like looking at the blocks and how they all fit together, getting rid of old blocks, remapping in new blocks, like we do all that. And then from RMAN's perspective, it thinks it has a full backup all the time. So we take an L1 today, it gets mapped into all the other blocks and we produce a recovery map. We put that back into the RMAN catalog. So when RMAN looks, it says, oh, I've got a full backup for today. RMAN doesn't really know that it didn't take a full backup. It just sees a full backup that it can use. So we're doing this efficient work behind the scenes and then populating the recovery catalog. So then RMAN then can use it in an efficient way when it's time to do a recovery.
Thanks, Kelly. Another one, really great question. If we can do air gaps.
Air gap. So air gap, everybody has a different definition for air gap. Air gap, what you're essentially doing is you're disconnecting the database from your backup destination. And that can be solves some problems, produces other problems. What we really want to focus on, and so one of the problems it produces, right? If I disconnect my backups from my database right now, that means that the database doesn't have a place to send backups. We're doing real-time protection of the database. To do real-time protection of the database, we can't disconnect our storage location from the backup, the database, because then you're producing a gap in your protection, right? And then if you have a failure, you have to think to yourself, oh, great, when did the air gap occur? And what database backups do I have that are after the air gap? Like that's a precarious situation to put yourself in. And for on-premises, in some cases, it makes sense because in on-premises, there's a lot more hands in the infrastructure, right? You could have a malicious attack that can get to the back-end infrastructure. In this particular case, the infrastructures are completely separated into different tenancies. The infrastructure that is actually managing the recovery service infrastructure is completely in a separate tenancy from the database infrastructures. So, and the only access is via RMAN. And that is happening through a private network connection between your database and the infrastructure. So the access point is very, very small and is isolated strictly to RMAN. That's the only access you have between one infrastructure and the other. So instead of doing air gap, we're being very, very conscious about the network traffic that is allowed in and the communication levels. And we're keeping the infrastructures completely separate in different management tendencies. So intrusion is complete, they're completely separated, which is a completely different paradigm than on premises where air gaps could be important because you have a lot of the same administrators, a lot of the same accounts administering infrastructure that's all on the same physical network. That doesn't happen in the cloud. So completely different concepts. And that could essentially be a topic that we could cover for cloud, right? It's a different paradigm. The other thing that's happening behind the scenes that we didn't talk about today, we always replicate the backups to two different infrastructures behind the scenes that are in two different locations. So there's always multiple copies of the database backups in multiple locations inside OCI. So again, another layer of protection that's happening behind the scenes. And we didn't talk about that, but that is something we could talk about as well.
Yeah, just to add on, Kelly, thanks for that explanation for OCI resident databases. There are some ideas on offering a air-gapped type of vault solution, I would say, for on-premise databases. I think that's something customers have been seeing from other vendors. They're, kind of the first step would be for recovery appliance on-premise to support replication into the recovery service, and then
yes,
to look at if that connection can be automated for air gap type of control. So it is a valid idea. I think there's justifications behind using the cloud as a vault, and that's something we would look at potentially for the roadmap.
Yes, I mean that gives you that third location that's out of your infrastructure. So again, a very powerful tool.
Yeah. There was a couple of questions I did notice were interesting too, about alerts and exceptions handling. Recovery service handles kind of the infrastructure part on the RA side, as well as there are integrations we do like with base DB service, which allows our side to be able to, Oracle side, to be able to resolve these issues without it surfacing to the customer. Now, for the customer side, what kind of incidents and errors could they potentially see, and how would they, find or submit those, right, for diagnosis?
Yeah. So, and I can give you a common one, right? And that I forced in our infrastructure in the database that we looked at earlier, right? I took a database down for maintenance. And we've seen this in a couple of customers where, over the weekend they took a database down for maintenance and backups failed during during that maintenance period because the database was down. And if the database happened to be having a problem where it couldn't communicate, when the failure occurs, and I don't have this in my particular one, but it gives you back there's a tracking ticket with every, we call them OSIDs, the OCID of the database. Then you could simply open a service request with support and tell them that, this particular backup failed, give them the OCID. And then we could look at that behind the scenes. So that gives you the capability of, you would open a support ticket just like normal. And you can target a specific incident via OCID so that it can be investigated. As Tim mentioned, we're doing a lot of monitoring from behind the scenes so that we understand, are backups occurring? Are there failures that we need to look at? There's an operations team behind the scenes that's paying attention to all that, both on the database side and on the recovery service side. So we've got two different operations teams that are looking at that.
All right. Thanks, Kelly. I know we're coming to the top of the hour. The other one was question about details on the sizing of the backup. And what do we expose today in terms of the backup sizing? And it's probably a more general question of what would a customer need to know for backup sizing, right? And which is potentially related to activity, activity history, and also to billing. Could you address that one?
Yeah. So I showed you in the UI, and we can look at that again, that we keep track of the backup. Let me bring this up. We keep track of the backups and let's see, the backup utilization. So let's go back and look at one of these databases, and I'll bring it up on the screen. So we keep track of the space used. And that also gets put into your cost analysis tools in OCI. So, when you go over here and you look at your cost management tools, your cost analysis, there'll be a line item for the recovery service. So it will show you in detail all the databases and the cost associated with those databases. So you have a really simple report. We also do projection, so you can determine your projected utilization. If you are a object storage backup user today, essentially the utilization is going to remain the same. Where we're using the same space paradigm that object storage is using from a billing perspective. So your bill's not going to really change unless you enable real-time protection of the database. That's the premium that's involved, and that's why I would have you take a look at the cost estimator. And what the cost estimator is going to do is going to ask you a couple questions about your database, like how big is your database, what's your change rate look like, and then it'll do the calculation to tell you based on your retention period, like I want to keep the database around for 30 days, it'll do a calculation and tell you what that estimated usage and cost would look like for that particular database or for your overall database fleet. Okay, so somebody asked, to estimate backup size and cost prior to deployment, how can we estimate size due to compression that RCV provides? Size, compression is a tricky thing. We don't know what you have stored in your database, so until you do a backup, it's difficult for us to determine what the compression looks like. For all we know, you could be storing images inside the Oracle database and they don't compress at all, which means you'll get no compression. You could be storing text and text compresses really, really well. So the easiest thing to do is look at your statistics for your database today that you're using on, if it's on premises, that's a method to do it. Or if you're using it in the cloud backups use compression today. So the compression that you're getting today will be the compression you get tomorrow because it's RMAN compression, and RMAN compression is the same for both the object storage and the recovery service in the cloud. So the compression ratio is a compression ratio. So there's then the follow-on question of that is there's incremental forever. Incremental forever is an operational savings. We're from a cost calculation perspective, we're using traditional cost calculation for estimating, or not for charging back to the customer. And that's in the cost estimator. If you look at that, it gives you an example in the cost estimator of exactly how we're producing a bill. But the incremental forever paradigm, the offloading of the validation, those are operational efficiencies that we're giving you so that you save on the database side. That's not a savings for backup storage. Okay. Any other questions? We're a couple minutes over. And so the last thing I'll say about the operational savings too is cycles on a database, a lot more expensive than storage for a backup. Like we want to make sure that we have very light operational impacts on the database itself, because those database resources are very expensive and it has a true impact to your business. We want to make sure that we are offloading all of that for you. And that's really where the true savings come from. Like when you eliminate that full backup, your database gets a huge breath of fresh air because it's not having to do that heavy lift every single week. All right. Oh, you know what? I'm going to be brave here. I'm going to go look. We're going to go look at, it hasn't completed yet. So the database we provisioned has not completed its backup. I just wanted to see if that had happened. Let's look real quick. The database we brought on board this morning. Let's take a quick look at it. Oh no, it's finished. There we go. So the backup completed. And let's look at the details. So this is the database we brought on this morning. Took about 35 minutes to bring it on initially. You can see it right there. So the database will slowly come to life, and all of this statistical information will get updated over the next half an hour or so. Notice that the database is still in a warning state because the first backup is still being processed, and that'll clear up. But yeah, the database came online. So the database backup completed. All right. And there it is. So these statistics will fill out, and then we'll have a new database online. Any final questions? I appreciate all of your questions today. The other thing that I think you've given us a couple ideas for things that we can cover in the future. We can cover a little bit about the air gap designs. We can cover a little bit about monitoring and billing. We can do a deep dive on that. So we look forward to talking to you all in the future, and we'll include some of these topics. How incremental forever works, how we're doing space management behind the scenes. These are all really, really good questions that'll lead us to additional topics in the future. I appreciate everyone's attendance. Are there any last questions that we need to cover? Anyone else on the call? All right, nothing else. So we will close it off for today. Thank you all so much. We'll look forward to you in next month's call.